Thank you, Bob. So, yeah, I don't do hurricane forecasts, but I can look backwards and look at where we were. So let's look at. Well, we'll jump ahead here. So this is. These are all of the hurricanes and tropical storms that have occurred since 1851, and you get the idea. Oops, there we go. You get the idea that Florida pretty much gets hit quite often. Okay, thank you, Bob. So those are the hurricanes. Whoop. There's a hair trigger on this thing. So hurricanes show in red, tropical storms in yellow, and there's a few purple storms in there, and those are the major hurricanes. If we look at just severe hurricanes, they're much more rare than that crowded map. And what you see here are Cat 4 and Cat 5 Atlantic hurricanes per year since 1980. Excuse me. And basically what you're seeing here is a trend from basically around 1980 from you either had one major hurricane or none. And as you move on, they become more frequent. And in the current decade, they're every year. These are Cat 4s and 5s. If you look at a rolling 20-year average, that 20-year average has doubled since 2000. So in 2000, it was about 1.2 per year. And by 2024, we're up to twice that. This is a longer-term look at the hurricane season. And as we all know, it peaks in September, and you can see it quite clearly here. Not only hurricanes, but also tropical storms peak at the same time. Given that they peak in September, it's also important to remember that almost any other month you can still get a hurricane. So you're not out of the woods just when you get either early in the year or later in the year. These are interesting charts that NOAA and the National Weather Service have put together that show locations most at risk from hurricanes. And for the purpose of this talk, the important things are that green zone all down the East Coast and over all of Florida, and then extending on the Gulf Coast almost as far as the American side of the Gulf Coast. The key thing here is at any point, at any place located in that green area, the chances are over a long period of time, the chances are that you're likely to see a hurricane pass within about 100, 150 miles of that point every 3 to 5 years. Well, that doesn't sound too bad, but anywhere in that green zone, you need to be prepared for hurricanes, but every 3 to 5 years, you can handle that. Well, the things are changing. This is the long-term average that we're looking at here just for the month of September when peak hurricane season happens. But so over the long term doesn't look so bad. But since 1999, we've had 18 major hurricanes hit continental US, and 17 of those were in the Gulf. Since 2017, we've had 10 major hurricanes make landfall in the Gulf, 6 of those hit Florida. So we look at the 2024 forecast. This is right out of the website, and you can see in 2024 we predicted, coincidentally, 24 named storms, 12 hurricanes, 6 major hurricanes. The last year on this chart refers to 2023, of course, it was last year. And 2023 was pretty active itself, 21 named storms, 7 hurricanes, 3 major hurricanes, that's category 3 and above. And if you look at the bottom line, the average hurricanes, that average is only over the period from 1991 to 2020. That's a 30-year period. It's the usual meteorological 30-year baseline that you use. And the average in that period was 14 storms, 7 hurricanes, and 3 major hurricanes. So we were ambitiously ahead of that last year. And also, you can see the reason that we forecasted so many storms and hurricanes are all down the right side there. Those are all the assumptions that we made that boosted the forecast way above the long-term average. And primarily the transition from El Nino in the Pacific to La Nina. The La Nina conditions favor low wind shear, which lets hurricanes evolve. Very warm ocean, lots of moisture in the atmosphere from that warm ocean. Relatively moderate Saharan dust. What we're really worried about is not so much the dust that blows across the Atlantic from the Sahara, but really the hot, dry air that carries that dust. And then African easterly waves, that's a meteorological phenomenon in between the monsoon area in the southern part of Africa and the dry desert area in the northern half of Africa. And the easterly waves form at that boundary, and those easterly waves go into the Atlantic and spawn hurricanes off of the west coast of Africa. So this is what actually happened. 18 named storms, 11 hurricanes, and 5 major hurricanes. And in those 5 major hurricanes, 2 of them were Cat 5s. And since 1950, only 4 other years have been recorded with more than 1 Cat 5. So last year was extraordinary. Remember that in 2023, we only had 7 hurricanes and 3 major hurricanes, Cat 3 and above. 2024 was also the 9th year in a row that we beat the 1991 to 2020 average. That was of 14 named storms, 7 hurricanes, and 3 major hurricanes. 9 years in a row. That makes you think that maybe that average isn't such a good predictor of the future. So if we look at it in a little more detail of what happened in 2024, let's look at the average. That's the blue area on the chart. And you can see that, it's the regular occurrence of hurricanes with a peak in mid-September, early September. The vertical axis on this chart is something called the accumulated cyclone energies. Basically, it shows a wind energy index. So the higher the value, the stronger the storm was. And 2024 is shown in yellow. So unlike the average, which peaked in September and got off to a gradual start in July, so what we've got here is an incredible start to the season last year. very fast start. It's the earliest Cat 5 on record ever. Lots of energy, so you get a big spike on the left side of the chart. What followed that, unfortunately, well, not unfortunately, fortunately, was basically a lull when we would have expected a steady flow of hurricanes peaking up into September. We got basically a dead zone in the middle of the season. And that was because those African easterly waves that we talked about a couple of slides ago decided to go on a vacation north in Africa and didn't end up in the main development region for hurricanes, so we didn't get any for the longest time. And then started to pick up again in September, and then you see the huge spike in late September and early October, and we're made up for lost time there. And we had a record 7 hurricanes after September 25th and 12 named storms after the normal early September peak. The average would be 14 storms for the whole season. We managed to pack 12 of them in to basically a month. This is where they all went. So the key takeaway from this chart is that the real action is in the Gulf of Mexico now. That's where all the activity was. Certainly, it's where all the damage occurred. So what's going on? Well, I mean, the reason that the long-term averages aren't working very well anymore is that the Atlantic Ocean and the Caribbean and the Gulf are all warming as the climate changes. And storms over the ocean are fueled by heat from excuse me, heat transferred from the ocean to the lower atmosphere. And a warmer ocean, more heat energy, more energy transferred into the atmosphere, more named storms, and more powerful storms. And this graph shows the steady rise in ocean temperatures from 1990. If you look at 1990 compared to the long-term average, we're at the long-term average. But then after the 90s, things really exploded in terms of heating in the ocean. And unfortunately, it kept going. If you look at the very right side of the chart, you can see the last couple of years were extraordinary in terms of how much the ocean warmed. The area that we're really interested in the Atlantic, that was for the whole of the North Atlantic. So that's all the way up to 60 degrees north. What we're really concerned with is what we call the main development region. That's a band of extends from the west coast of Africa over into the Caribbean. And the main development region, we have the same idea, same sort of trend. We're looking at the recent history now. And the sea surface temperatures in the main development region are well above the 30-year average. The graph shows relatively steady heating over that whole period. If you look at the right side, in the recent history, since 2020, every month has been hotter than the 1991 to 2020 average. So we're not, I like to think of that in terms of, beware the long-term average, because it doesn't really tell you a whole lot about the future in this case. Things are changing too quickly and changing too much. This is just for September, and that box in the middle of the map is the main development region. And this graph of temperature anomalies in the global ocean shows that within the main development region, we've had steady heating across the entire MDR, and excuse me. And in September, we're also seeing all that heat is equally located in the Gulf of Mexico. So the whole area that we're concerned about, from the coast of Africa into the Gulf of Mexico, are all well above average in terms of heat available to power hurricanes. And what happened by the middle of September is that the African easterly waves that had abandoned us in August had returned and started their job of spawning hurricanes off the west coast of Africa. And a result, with all that heat, was a very active late season. The average, well, we talk about a late season, that's roughly September 10th to November 30th. And the average number of storms in that period, tropical storms, is 6, and then four hurricanes and 2 major hurricanes in that period. In 2024, we had 12 tropical storms. 8 of them were hurricanes, 4 of them were major hurricanes. And if you look after late September, about the 25th onward, we had a record 7 hurricanes after September 25th. That had never happened before. So what happens with all this heat in the ocean is that hotter oceans result in higher winds in the hurricanes. And this is a chart from Climate Central, an outfit that does tremendous work looking back at the relationship between climate change and weather of all sorts. So remember that the Gulf of Mexico is now dominating the hurricane picture. So hurricanes, if you look at hurricanes in terms of the warming ocean, hurricanes are basically heat engines. They take heat from the ocean and transfer it into kinetic energy in the atmosphere. Kinetic energy meaning wind. More heat, more wind, higher winds. And that's exactly what this chart shows. The light gray symbols for each hurricane from 2024 is what the strength of the hurricane would have been had the ocean temperature had been at average, the average that we've been looking at. Now, the temperature is well above average, so the result was all of those hurricanes were strengthened by quite a bit. Analysis shows that basically the maximum wind speed of every 2024 hurricane was higher than it would have been without that extra ocean warming by 9 to 28 miles an hour. And that heating results in, quite frequently, in rapid intensification. That's when the hurricane explodes from one category into another in a short period of time. Rapid intensification happens when the increase in maximum wind speed is at least 35 miles an hour in just 24 hours or less. Um, in 2024, that happened for 5 storms. That's unprecedented, basically. Hurricane Milton, which you can see on the extreme right side, exploded excuse me, exploded by 95 miles an hour in only 24 hours. It went all the way from a Cat 1 to a Cat 5 in 24 hours. And all of this is really related to the changing climate and the effect of that changing climate on the warming ocean. And this looks like a temperature chart, but it's not. It's actually looking at how unusual the temperature is in each of those areas. Dark red to brown means that those areas are basically 100 times more likely to have occurred with a changing climate than they would have been with a stable long-term climate. For Hurricane Milton, the peak intensification for Milton is where the curly symbol for the hurricane is off the coast of Yucatan there. And it was made basically 100 times more likely to happen, increasing the wind speed at maximum by over 23 miles an hour at just that point. And 100 times more likely than it would have been in a normal, well, in the long-term average Gulf of Mexico. So let's take a look at the 2 big ones. This is Milton, of course. It was not just bad news for us, but it was bad news for the whole of the Earth, because it's the strongest tropical storm on the planet in 2024. Stronger than any of the cyclones in the Pacific, the strongest late season hurricane ever recorded in the Gulf of Mexico. It's also the 5th most intense hurricane ever recorded in the Atlantic Ocean. Total damage from Milton, 34 billion plus. And then, of course, Hurricane Helene, which is the deadliest US hurricane since Katrina in 2005. 249 people lost their lives directly because of the hurricane. Historic levels of rainfall and inland flooding because of the hurricane, the strongest hurricane to make landfall in the Big Bend area of Florida. Damage, almost $80 billion. If you look at the season as a whole, we had 5 billion-dollar hurricanes in 2024. The worst ever. I mean, excuse me. The thing about the strength of wind speed obviously creates related to the damage the hurricane can cause, but it's not a linear relationship. It's logarithmic, in fact, and a 10% increase in wind speed in a hurricane doubles the damage that's done. And so if you think back to that intensification chart for the Gulf of Mexico and all of those hurricanes that were accelerated by the warm water in the Gulf, then you can look at that warm water as the principal cause of a lot of the damage that was done. And for Milton and Helene, almost half of the damage from those hurricanes was attributable to climate change, that they, in a normal climate or in a previously normal climate, the damage would have been only half what it was last year. So the three Cat 5s the three most severe damaging hurricanes in 2024 were the biggest weather and climate disasters in the United States for the entire year. And that was even though the reality was a little bit less than our forecast. So I have no idea what the 2025 forecast is. Bob wouldn't tell me. So it'll be as much news to me as it is to you. But I think I'm pretty confident that we're not going back to the long-term average. It's going to be beyond that, I hope. Well, I don't hope it because of the damage, but I hope because it'll make me look like I know what I'm talking about. And I guess that's all I have. I'll take questions if anybody has. Yes, sir.
Dr. Stu, you showed the path of Milton, which kind of started in the Pacific.
Questions to get us back on time.
Started in the Milton started in the Pacific, jumped over the, basically Mexico into the Gulf. Mm-hmm. But it had been 150 years since a storm had that particular path. Do you see that kind of a path being more prevalent going forward?
I don't know that we have enough data to really answer that question. I think it's still going to be a rare occurrence. But you're right. I mean, it hopped over, but it was only a modest Cat 1 at that time when it hit into the Gulf. And by the time it got to the Yucatan Peninsula there, where it showed in that chart, it was already a Cat 5. So, I mean, the real damage came from the heat in the Gulf of Mexico. But I don't know how often that is likely to happen. I think it's pretty rare. Bob, do you? Yeah. Never happens. Never happens. Okay. Very rare. Yes.
Question for you. So Hurricane Ian, I think that was 2023. I didn't. Just curious of the damage of Ian. I think that was 2023. I know that it wasn't up there on the screen, but do you know what the damage was in dollar figures for the state of Florida?
No, I don't.
It was 112 billion.
There you go.
Stu, over here.
Sorry.
So the question is, with the facts so compelling that climate change is real, why does that create such a polarized response among much of the population and especially among certain politicians?
Well, I wish I knew the answer to that. That would be nice. I think people don't like change really, and I think that, and they especially don't like change if they think it's permanent. And we've made climate change relatively a permanent facility, a permanent aspect of our lives going forward. And the things that climate change carry with it, like the increase in the number of hurricanes, is something that we are simply going to have to adapt to. And like I said, it's, beware of the long-term average. People look at the long-term average and say, oh, well, it's not so bad. It'll go back to that. Well, it doesn't look like it'll go back. It may not go up every year, but it won't go back.
Yes, thank you. Thank you for all your data, amazing. And following up on your question, so you've got a long-term average, the stats are there, you seem like you're 98% confident of your averages, right? There's no refuting your average, correct?
I'm sorry, what was?
There's no refuting your averages.
yeah,
And there's no refuting what has taken place over the last 20 years and the last 5 years. So within your context, following up on what he just said, what would it be for the next 10 years? Because most people can't think beyond 5, but taking 5 to 10, do you take a stab at what the statistical averages would be, or the statistics of why are we giving people hope that 3 years from now, it'll be different? We have hope that it won't be the same. But coming from such esteemed scientists as yourself, what is the science proving over the next 3 to 10 years, not 20, not 30, because I can't think that way, but the next 3 to 5, 10 max, that your charts are showing this is what it will be with 90+% confidence from esteemed bodies like yourself?
I don't think I've ever been called esteemed before.
Maybe
However-
steamed, though. Maybe
Oh, yeah,
steamed.
I definitely steam, but I'm not, yeah, anyway. Well, forecasting climate change is very difficult, is the bottom line. I mean, we know it's going to, the way things are going, it will get warmer. We're concerned about the warming oceans. The oceans warm very slowly, but once they start warming, they'll keep warming going forward, almost regardless of the weather. So the variations in hurricanes, a number of hurricanes and their severity going forward is going to be due more to changeable things around the edges of climate change, things like the Eastern African waves. If they move, then hurricane formation changes, that sort of thing. But fundamentally, we're committed at this point to a warming ocean. And that means that we're committed to an average number of hurricanes steadily increasing over time. I don't know how many. I just don't even know how many we're forecasting for 2025, because Bob won't tell me. But I think we're not going back to the average, let's put it that way.
Maybe I could jump in too, is 5 years ago, 4 years and change ago, the CAC made an unprecedented forecast for a local area using climate warming. And we did it because we thought, A, we had the skill to do it, and B, because it would be something that people could point to and say, this is what it's likely to be. It probably isn't going to be perfect, but back in 2018, we said the number of hurricanes and major hurricanes would probably close to double by 2050. And we're well on our way to that. We also forecast that the sea levels, which have risen roughly 8 to 10 inches here, are going to go up another 8 to 10 inches by 2050. The rate of sea level rise is increasing as well. So those two things aren't great in the sense that we're a low-lying area, you know, a lot of our keys are roughly 5 feet above sea level. And if you lose 2 feet of that to a rising sea level, then even a mundane storm is going to do much more damage. And we have a large population now attracted to the most dangerous places. And so the thing is, we know this with high confidence. This is not like, it might. I would like to say high confidence, not 100%, but if I could take a bet where I could win 70% of the time, I would make the bet every day. And that's where we're at. So, yes.
Hi there. My question is, what factors of climate change are attributing most to warming the waters in the Gulf Coast?
Well, climate change is trapping more heat over the land and the ocean. And normally, the radiation from the sun warms the ground, warms the ocean, but a lot of that heat then gets radiated back and lost to the atmosphere. Climate change effectively is making the atmosphere less, well, it's like putting an umbrella over the ocean. It traps the heat. It doesn't let as much of it escape as it used to. And so that heat stays in the ocean and increases every year over year. So it's really what happens in the atmosphere in terms of climate change that affects the ocean. And it takes a long time. As I mentioned, the ocean is a huge object all by itself. I mean, it's miles deep, and it takes a long time before the change in the ocean starts to become apparent. But by the same token, it keeps going. Once it's rolling, you're making it stop is going to be very difficult. We could, once we stop changing the climate in the atmosphere, the oceans are still going to be warming, and it's going to go on for quite some time. And that's really the thing that's going to affect hurricane forecasting going forward. Not so much what happens in the atmosphere as what's already happened in the ocean, if that makes any sense. Yeah.
Good morning. I'd like to go back to the Milton experience. And I remember last year, I think if I recall correctly, you emphasized the warmth of the Gulf and the propensity for rapid intensification of hurricanes. And we saw that in real time with Milton. And you had a graph up a minute ago that said it increased from a Cat 1 to a Cat 5 in 24 hours. So I've got like a two-part question. One is, the track of Milton, you said, was kind of unusual and very rare. And I take comfort from that, because the idea of a storm occurring in the Gulf and then has no place to go but east towards us, that may be rare, but the intensification seems to be less rare, the rapid intensification, because we had that in storms prior to Milton. And it raises the question with Milton as an example of how little time you have to react to the intensification of a hurricane. Yeah. Milton, I'm asking you to, if you can, to remind us, Milton hit on October 9th, and I don't remember how many days before that it intensified from a 1 to a 5, which would effectively be our warning period. Three days, 72 hours?
Yeah. It wasn't a Cat 5 when it crossed the coast, fortunately. It had weakened a little bit.
Well, Bob and I have discussed this. I have wind readings that were on Beneva at Country Club of Sarasota of 123 miles an hour peak at 97 sustained, which are greater than, I just looked at the report from the National Hurricane Center for what they said. They said that Milton had maximum winds when it hit landfall of 107 and sustained at 90. The reading I had, which I just happened to take a picture of, I had evacuated, and I took a picture of the readings I was seeing from, what's the weather site? One of those local weather sites, it collects different locations. And I can show you the picture of 128 and 97.
One thing about that is that People don't realize this, but the roof blew off the airport. And when it did, it crushed the anemometer. So the anemometer stopped recording before the peak wind. But nobody reported that.
Right.
So the peak wind at the airport was 102, but that's when the anemometer got crushed. So that doesn't mean that was the peak wind, right? It was just the peak wind from that record. I'll never forget when he sent me that. I said, yeah, that's more like it. Where's Jim?
But
Jim was out on his patio at that moment, right? Both of you, Nina and Jim. I was hunkered down in Colorado so that we had coverage because I was afraid Rick was going to lose his power, which he did. And part of his roof. And so what ended up happening is I'm on Zoom with Jim, and I said, okay, go out on your patio now. You have 10 minutes. And he looked up and he said, oh my God, the stars are out, right, as the eye went over. And then I said, go in now. Right, and he said on the back side, it was so much more intense than on the front side, which is exactly what we said was going to happen with this storm. And that's when the roof blew off the airport and all of that stuff happened afterward. The 6.5-foot storm surge hit the Bay Park with a 3-foot wave on top of that. And, it could have been worse.
yeah, it could have been a lot.
It was bad.
Could have been a lot worse. I mean, it hit as a Cat 3, but in the middle of the Gulf, it was a Cat 5 with wind speeds up to, I think, if memory serves, close to
185.
180 miles an hour, 185. So it could have been a lot worse.
Okay, we got to move on. Thank you, Stu.